Lewis dot structures of atoms first. Lewis dot structures are also called Lewis dot diagrams, and sometimes they are also called electron dot diagrams or electron dot structures. So how do you represent them? So any element, so this X represents the symbol of element. It could be any element, okay, from the periodic table, and this is showing the nucleus and inner shell electrons. And this dot here showing the valence electrons. So this is the representation. This X is representing any element, symbol for any element, which includes the nucleus and inner shell electrons, and the dot, the valence electrons only. So for A group elements, group number is equals to valence electrons. Now where are our A group elements? These are the representative elements. If you look at the periodic table, on the left and on the right, they are A group elements, and in the middle you have B group elements, like this. This one, group 1, it's all 1 valence electron. Group 2, all 2 valence electrons. We are not talking about the B group elements, so you're going to hide B group elements. Here group 3 is 3, which is actually 13, 3A, 3 valence electrons. This one 4, group 5 is 5, 6 is 6, and this halogens, which is group 7, is 7, and the last one, noble gases, is 8 valence electrons, except this helium, which has 2 valence electrons. So you should be able to fill it now, the chart. Group 1, as we just said, that for A group elements, group number is equals to the valence electrons. So group 1A is 1 valence electron, group 2A 2, 3A 3, group 4A 4, 5A 5, 6A 6, and 7A 7, and 8A 8. And how are you going to show the Lewis dot structures for elements from these groups? So you will have an element from this group, only 1 valence electron. From group 2A, you will be writing the elements that you're working on, then 2 valence electrons. Group 3, all elements from group 3A, 3 valence electrons. 4A, 1, 2, 3, 4, and then 5, 1, 2, 3, 4, 5, and then this one is 6, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, and then there is not a very hard and fast rules. That's all up to you how you want to put the dots. But if you want, you can start from the right side one by one, like 1, 2, and then you're going anti-clockwise. 1, 2, 3, 4, 5, 6, 7, and then 8. If you want that. Right? So first you write them singly, and then you start them doubling up. So if you are given an element with 15 electrons, you can write electron configuration as 285, or you can write as 1s2, 2s2, 2p6, 3s2, and 3p3. 10, 12, and 3 is 15 electrons. So here you're going to look at the last shell, third shell, 2 plus 3 is 5, and here if you do like KLMN shell, then this is 5 valence electrons. You look at the periodic table. Now this element with 15 electrons is phosphorus. So you're going to write the symbol in the middle, and since it is 5 valence electrons, this is 1, 2, 3, 4, 5. So that's how you're going to write the Lewis dot structure for phosphorus. So here, as you go from top to bottom, here, look at the valence electrons. 1, and then 1, and then again 1, again 1. Top to bottom, 2, 2, 2. Top to bottom, 3, 3. So as you're going top to bottom, as you're going down the group, the number of valence electrons are not changing. But again, the helium is an exception. But however, if you go from left to right, these are the periods 1, 2, 3, 4. The left to right, the electrons are increasing, the valence electrons. So here it is 1 for hydrogen, 2 for helium, and then for lithium is, you're going to look at the valence electron 1, but then for beryllium 2, for boron 3, carbon 4, nitrogen 5. So as you're going from left to right, the number of valence electrons are increasing. So from top to bottom, as you go down, they remain same. From left to right, the number of valence electrons increasing. Okay. Let's work on this chart. You have these elements from periodic table: lithium, neon, chlorine, and carbon. When you look at their group numbers, lithium belongs to group 1A, neon belongs to group 8A, chlorine belongs to group 7A, and carbon belongs to group 4A. And in order to look at the total number of electrons, you're again going to look at the periodic table. So how many total electrons are there in lithium? Look at your periodic table and you're going to see there are 3 electrons, the total electrons, total. And how many in neon? 10 total electrons. Chlorine is 17 total electrons. And for carbon, it is 6 total electrons. When you write the electron configuration, look at only the valence electrons, 1. So here group 1, 1, so 1 valence electron. And how are you going to do that? You are going to write the symbol of an element, and that's just 1 dot. Neon, you have total electron 10s, but when you write electron configuration, 8 in the outermost shell, and also the group number is 8. So valence electrons are 8. 1, 2, 3, 4, 5, 6, 7, and 8. Chlorine, total electrons is 17. However, the valence electrons are 5 plus 2, which is 7, and also is the group number 7A. So valence electrons 7, 1, 2, 3, 4, 5, 6, 7. And then carbon is in, the total number of electrons are 6. However, the valence electrons are 4, and so is the group number. So write 4, and carbon 1, 2, 3, and 4. Okay. All right. Now this is your turn. I want you to try. Please look at your periodic table. Find out the valence electrons. So you need to find out the group number of each one. Look at the valence electrons and then put the symbol in the middle and then the Lewis dot. Pause the video, try it. If this is what you got, then you got it. Good job, guys.